So let's dive into today's episode together with Jeroen Overmars, my colleague. Before even going into the topic, maybe you can introduce yourself really shortly.
Yeah, of course. Nice to be here. Thanks for the intro, Diederik. I'm Jeroen Overmars. I'm a machine learning engineer working at Xebia Data. And what that means is that as a machine learning engineer, I help companies take machine learning applications into production. So that revolves mainly around ML ops, but also most importantly, LLM ops. So I work a lot with all sort of different customers on generative AI use cases.
Okay, cool. Well, nice to have you here, of course. Happy that you're here. So my name is Develing. I'm currently the CTO of Xebia Data and AI. And apparently in my spare time, I also do podcasts. So here we are. So today we're going to talk about production use cases that we as Xebia implemented for our clients that basically save some time or effort or improve the process for our clients. Can you maybe give a high-level introduction about what are we going to talk about today? How are you going to pique our interest?
Yeah, of course. Yeah, like you said it. So we're going to look at production use cases, specifically related to generative AI, which we automated some part of the customer process, right? So with generative AI, there we took a look at some business process, saw some improvement potential. And then made a solution to tackle that. So specifically, we're going to talk about GenAI for data extraction. So we have a couple use cases lined up where we can dive more into that.
Okay, cool. And maybe going into data extraction a little bit. So maybe for the viewers that don't know, what is data extraction? So how would you classify it?
Yeah. So a data extraction is when we take an unstructured piece of information, unstructured document, and we want to convert it into a structured format. So something that computers can work well with. So unstructured, for example, a long piece of text, a TXT file, or a Word document, a PowerPoint, an image, audio file. That's all examples of unstructured data. Okay. And then structured, that can be, for example, JSON. So where we have a schema and all the data adheres to this schema. And then that's a structured format of perhaps the same type of data, but we try to represent it in a very different way.
Okay, and would you call them Excel sheets structured data?
As long as you have, so if you create quality Excel sheets, right? You're a bit consistent with your Excel sheets.
Yeah.
So you have consistent columns, and then you keep all the rows tidy. Then it's structured. Yes.
Yeah. So basically, unstructured indeed is an image or maybe an email. An email would also be generally unstructured data, right? And then the idea is that the data extraction is about getting that unstructured data and putting it into a structured format. Like our example, that an Excel sheet, but it can also be a database, a data lake, or anything of that type of structured storage, let's say.
Yeah.
Okay.
Yeah, exactly. And so the reason that we're now talking about it and that we are discussing these customer use cases that we're doing with GenAI data extraction is because it's a recent development. So ever since LLMs became more popularized, more widely available, this unlocked like a different level of data extraction. So we can do a lot more. Models are multimodal these days, so can handle more types of data. And that's just talking about using the same model that you might consume from some model provider as an API, so you don't do any training, with which you can do quite a lot of things.
Okay, that's okay. So that's interesting, and that has been something for the last few years. Then, so now we have GenAI, which can do that or is better at that. But before we also had technologies that were able to do that, right? So what is new about GenAI, or why is it better?
Yeah, exactly, right. So we have had data extraction before as well. So where you have natural language, then a way to extract still some structure from that, that's the field also of natural language processing. And for example, when you are wanting to extract entities from a text, this is a technique called named entity recognition, where that's a technique that's been around for way longer. But since GenAI, so there's a couple ways that this differentiates when we get to GenAI. So one of the biggest is that we don't pre-train. So we don't train, we don't set up these models custom ourselves. But instead, we can consume that as an API. So the prompt in a way is a part of configuring your model where you previously had your own data set and trained it. So you can specify some of your domain specific knowledge and instruction in the prompt itself.
Yeah.
And
So would it then mean, did it become more simpler as well of setting a post up like this, where before you probably needed to do something which is technically challenging, and now you can just write a prompt and it should work? Is that then what you're saying effectively?
Yeah, so it's not, of course, as easy as that. You will need to take into account setting up proper evaluation pipeline, ensuring that the quality of the extraction is up to par. But still, with generative AI, you can get a whole long way already in a shorter time span. So your development time can be a lot shorter. And in some cases also with using GenAI, either the quality of extraction can be improved, or even extraction where previously not possible can be realized. So thinking about these multimodal use cases, for example. So it's indeed a different game. So we can also see that companies are really enthusiastic of getting some benefit from the potential, basically, from all these new technologies. So that's what we try to help them with. Okay, cool. And do you have any specific example of this? Like, so we're talking about production use cases. So can you maybe name an example? Yeah, for sure. So let's dive into the first example here. So we have worked with an insurance company. They are called Klaverblad, and what we did is we set up an agent that helps process insurance claims.
Okay.
So what this agent does is, given information that an employee provides, it goes out and looks for similar insurance claims. So previously, this is a process that happens manually. So insurance claim employee goes through a database to find similar cases. So the reason that they have to find similar cases is because you use that to reason about what is a sensible amount of money to give to their customers, right? So you want to reason about that, find cases which are as similar as possible from the past, and that the employee spends a lot of time going through that database, also understanding the piece of text that a customer provides. So they typically send it through email. So they email this insurance company with their entire story, right? In this case, they are accident insurance claims. So a customer has had an accident and there's a whole description about it. So maybe they fell off their bike, broke their wrist. They cannot do their occupation anymore. So they require compensation for that. So what we then do is two things. So we take the text as a whole and we try to match that against other descriptions. So that is using vector similarity search. So that's a big topic in RAG. So that's converting the text into a semantically meaningful vector, and then compare those. But more importantly, for this topic, we take the text and we extract some structure from it. So what is some structure that we can extract from insurance claim text? The occupation of the customer, their age, the type of accident that happened, which we can then in the prompt also insert the different categories that this insurance company has. So choose from some of these categories.
Yeah.
What level of accident is it? Is it a light accident, medium, or heavy? And give us all that information structured, which we can then use on our turn to filter through all these entries in the database.
Yeah, okay. So it's twofold basically. So one is indeed let's say the ingestion part of the data. So you get an email, right? You need to parse it into a structured format, I would assume. And then the next step is that comparison, right? So based on the structured data that you have now, you can compare it to similar use case within your database. And then from that, effectively, you can determine how much money should be paid out by the insurer. That's effectively the two-step approach, right?
Yeah.
Okay.
Yeah.
That already seems like a relative complex system. Are there any? So, what are the challenges with implementing such a system? I can imagine that there are multiple.
Yeah, exactly. That's a really valid question. So, when explained, it's easier said than done, right? But we want to get systematic about the solution and create guarantees also to the customer, right? So what guarantee can we give about the quality of extraction? So we set up a system and then it extracts all that customer information. Let's evaluate that systematically. So the customer can also get some insight. Hey, we are extracting this property from your email data. We took some samples from the extractions. We labeled them also with humans, with subject matter experts. So in this use case, it was super important to stay very close to the subject matter expert and work together with them.
Yeah, for labeling the use case, you mean? So whether something is has a high impact or a low impact. That type of labeling, you mean?
Yeah, exactly. Yeah, okay. Yeah, indeed. Yeah. So the labeling, and there we can see that maybe you can see by looking at your evaluation data that you systematically get some couple properties wrong, right? So, I mean, maybe something is going on in the data. Maybe your extractor is handling this case very bad. So that's something to look out for. But yeah, that you want to keep into account, right? So I think that is one of the challenges. So it's not like a magical one-time operation where you just set up the system, it's done, right? So it requires also work, but then it can do a lot of work also for you, right?
Yeah. But the need for this to work, you need to have that feedback loop, right? So you need to know what is correct and what isn't correct. Correct?
That is essential, right? So that's the human in the loop that we often hear about.
Yeah.
So we want to indeed get that feedback from our system running, right? So during development, also when the system is running, in both of these cases, we really want to keep an eye out for things.
Yeah. And would you say that holds true for all of these type of, let's say, automated data extraction systems that are built on top of GenAI, that you have such a feedback loop in place, or are there also other scenarios that you should take into consideration?
So I would say so how critical is the performance of your extraction, right? So you could also argue, okay, we are replacing some manual process by this data extraction mechanism. Anything more than nothing is better, basically. So if you have a use case where you're just helping out or doing some maybe some analytics and you're kind of aware, maybe just taking a couple samples and then this property extracts pretty well. So I would say how critical does it matter that your extraction is correct, right? So maybe you're doing something that is not nice to have, right? But something is not critical. But there I am actually curious. So do things pop in your mind as well about this?
About this topic?
Yeah.
So I think there is, right? So if I look at most of the clients that I talk to, and especially the different type of use case that they have, I think that there's almost always still a human in the loop, or it's not a fully automated process yet, right? Where literally, you have something happening, then an agent or an agentic system, it does an action, and then automatically it's forwarded without any, let's say, human in the loop type of interaction. And that kind of makes sense, I think, because over time we need to build trust in these type of systems, especially since these are non-deterministic systems, right? Meaning that, well, you're not always 100% guaranteed that you will get the same output every time. Of course, there are ways to force this somewhat, right? But nothing is perfect yet. And I think that organizations need to build up trust with these type of systems, but also, basically get more knowledge about how to properly deploy these systems, right? So what type of guardrails you need, just how do you monitor these type of systems? How do you log them, et cetera, et cetera. Mm-hmm. And the moment we're there, I think we're going to move a little bit more into, let's say, the fully automated aspect of things as well. But for now, if I look at what I'm seeing, most of our clients, there's still always some type of human in the loop step, or data is just being used, but not automatically, let's say. Yeah. So that's, at least that's what I'm seeing. Yeah. And I think you're seeing the same, right?
Yeah, well, I want to tap into something that you said. So we talked about evaluating and then taking samples, like labeling that, but I also heard you mention guardrails.
Yeah.
Maybe for also the listeners, right? What is the difference there between evaluation and guardrails?
That's a good question. So indeed, so when you have guardrails, right? So when you have output, for example, from your model, you would put guardrails in place to basically, check if that output is actually up till some standard that you're looking for, right? So it can be that you have a guardrail which is just a blacklist of certain words which can never be mentioned, or certain topics. Another guardrail can be grounding, where you say, okay, I have some type of database that I want to check all information against before I send it out to my next system, let's say, right? And these are more what guardrails are, I would say. And then you have your, let's say, your monitoring and logging part, where you basically track all outputs and try to determine what type of quality your output is, and if it's, if, let's say, this quality is improving and you're checking properly your performance over time. So I would say that's the separation between the two, right? So guardrail is right now for, let's say, the output of a model, right? Will it get passed? Do we still need to change it? Will it just get fully blocked, right? That's what guardrails are being used for. Mm-hmm. And then you have your monitoring and logging and observation stack that needs to track over time whether the quality of our system is improving or not. Yeah. I would say. So do you agree with that separation, or do you have a different definition, let's say?
Yeah, I can very much align with how you phrased it. So with guardrail, indeed, right? So you said that it's returning the quality of result, or the result that you are wanting to the system to return. So all right, so there, when I think about guardrails, so the most typical example is protecting against like unwanted, maybe dangerous hate speech type of outputs, right? So don't help users create some type of poison or whatever, but it can still be very knowledgeable about all chemicals, right? So still having that knowledge, but not going in a certain direction. But so do you then also cover in your definition of your guardrails, topical guardrails, or just making an agent system only for one purpose, or would you separate that somewhere else?
So you mean that you create a set of guardrails for a specific agent, or you would make them more generic, let's say? Is that your question?
So the agent should stick to only one topic, because that's what it's built for.
It's a good question, right? So I think that because we're kind of going into the domain now where still a lot of research is being done, but I would say that every agent, right? So agentic agents should have their own one specific purpose. So nowadays, what you see with a lot of multi-agent systems is that you say, okay, I have 5 or 6 agents that connect to a set of tooling, right? So MCP, generally using the MCP protocol, right? And then I have some type of orchestrating agent on top of it. And I think that what as shown is that if you set it up in this way, right, then the performance of your overall system goes up instead of having like one agent that's really generic that's connected to a lot of MCP tooling, right? Because then an agent can get confused, right? There will be a lot more hallucination will be happening, and that is why why we think that just having one let's say one purpose per agent or one agent per purpose, I should say, that tends to work better. And then you can also set specific guardrails up for those specific agents, let's say. That's how I would tackle it currently. Of course, there's always, let's say, your generic guardrails. So a blacklist, that's of course something which you can pull over all your agents if it's applicable, of course.
Mm-hmm. Yeah.
So,
okay, yeah. So splitting up your functionalities in sub-agents, if you will. So you say has both the advantage of one model not being overwhelmed by the amount of context that the extra tooling provides, but also gives us more the flexibility to set specific guardrails for that agent.
Yeah, indeed. That's effectively what I'm saying. Yes, and I think that that is where we see those type of systems going now, right? If you look at the multi-agent systems, then that is, those are the type of developments which we're currently seeing. But to be honest, if we look at data extraction, right, I think most of it is still being done more in like this single agent, single LLM kind of fashion, right? Or do you already see data extraction systems that have multiple agents? So maybe do you have an example of that, of maybe an use case which uses multiple agents for extracting data?
Yeah, I think indeed that's a good time to talk about the second use case. So when multiple calls, like model calls, multiple different models are involved, and what we often see is maybe some critiquing, review, validating agent which checks the output of the first model. So that is something that we can also do in this second use case. So LLMs can also work with images. So one use case that we have helped a client with is ingesting menu cards. So their LLMs can very well, using its multimodal capabilities, understand also the layout of the menu card, convert it to structured format. But I want to use that use case, which we all understand has as an input images, to actually talk about a more auditing type of use case. So where we have a PDF document, and we try to answer questions about it. So say, for example, that we are interested in how well is Xebia performing. So we have this annual statement, and that can be a pretty long document, right?
Yeah.
So some big companies, they have documents of hundreds of pages where they go all about the statistics of their financial performance and such. So maybe we can use LLMs to understand the document and answer questions for us. So why did I mention images? So when you give a PDF document to a model, to, for example, Google's Gemini, it actually inputs as images. So 300 PDF pages will actually translate to just using 300 images.
Okay.
Yeah. And so actually to explain this former use case, let's actually take a look at a slide.
Yeah.
So we can here see what I just explained. So we can have some audit questions plus this annual report. So yeah, this is also a company that we work tightly together with, which we can then in automated fashion create answers for, which will already save us a lot of time drafting out these answers, right? With, most importantly, on the right-hand side, a citation to where this is found in the document. So this is an example where we do not leave out all the functionality, all of the responsibility to the LLM for just providing us with clear-cut final answers, but it's a draft. As a human, we're going to look at that. We can verify and validate whether this is correct because we have these citations there.
Interesting. Okay, but this is still a single agent system, right? So you would have multiple agents in this type of system yet. It's more about you having a very big PDF that you want to parse somehow and being able to ingest.
Yeah.
Okay, clear. And then why is it important that they are being, so that they are loaded in as images? Does that mean that also spatial type of tracking or is being done by these models effectively? Can you maybe say something about that?
So the important realization there is that this opens up for us the possibilities for many type of unstructured data formats, right? So we have a PDF, it might as well be a Word document, a PowerPoint. So the multimodal models these days, they have very good also OCR, optical character recognition capabilities, right? So you can have it as this document which has, so PDFs, they have no predictable structure. That's just images and text. You can read it out digitally, but it might as well be really an image, which also you cannot in the PDF file format find raw text. But that abstracts that away from us, that we can work also with documents in many types of formats.
Okay, clear. And can you maybe say a little bit about what was gained here, right, from a business perspective? So you mentioned the Klaverblad use case, you mentioned this use case. So, did we save like half of the people's time, or, was there a clear, let's say, improvement, time saving, or something like that with these type of use cases?
Mm-hmm. Yeah. So coming back to the beginning of this session, right? Production use case that saved customers time. So this saves customers a lot of time, right? Because we go from a situation where we have document which is dispersed over a large document. So this might also be a report of 3,000 pages because the larger Gemini models support up to 3,000 images in its context at once, right? 2 million context window token. And that allows us to find the information that we need and point the user to that information. So we here have the LLM as like a workhorse trying to give us best draft as possible for these answers. We can check it, we can validate this is correct. So the reason that I'm emphasizing that checking and these citations is that we really want to take away also for these type of use cases the scary feeling about letting the LLM take over control or do so without our supervision. There's in the industry there has been a bit of a reality check with the hallucinations, right? So we need also to be a bit smart about it or double check. So that's where you can have two models working together, right? Then it becomes more multi-agent system. So one gives you the draft, the other checks it, preferably actually a different model doing that, right? So coming from a different model perspective altogether, which checks it. And they can kind of work together like that.
Yeah, maybe indeed. So I heard you mentioning something. So, and this is one of the scenarios, right? So you mentioned again having that, context, that source, right? That you can point back and say, okay, this was my original value. Here that it came from. But you also mentioned a set of scenarios, let's say, where you have fully automated, but then you have this type of feedback loop, right, where you have still data that you trace the source, you check it, and someone needs to approve it, for example, before they can continue. Can you maybe go a little bit more into those automation levels, let's say?
Yeah, for sure. So we have talked about a couple use cases, so we can see that some use cases we try to tackle in a varying level of automation. So let's pull up this table. So here we can see that we have 4 levels of automation. So level 0, no automation, right? Manual. The human performs all work. So whereas in level 1, we have the human assisted with tasks, but still in control and responsible. So that's assisted. So still the human in the loop. Whereas autopilot, it's a bit the other way around, right? So the human is not assisted, but the human supervises. So the LLM has the main responsibility there, and the human only kind of guides the process, but still for sure supervises, like is still in control, right? So still human in the loop. Whereas in the last level, autonomous tasks are fully automated. So this is the only level where the human is not in the loop. And to be honest, also the level that is hardest to get to. Because in order to let your extraction system or your GenAI application take full control, you better be very sure.
Yeah. I can imagine, right?
Yeah, indeed. So yeah, we like to think in terms of these levels, 1 to 0 to 3. And I am actually curious. So now that I'm lining up all these levels, how does that resonate with you? Do you think, okay, I would just always pick assisted or always autopilot, or what's your reasoning there when you do work with the client?
Again, a good question, Jeroen. So it depends upon the use case, right? I wouldn't say go directly for a fully automated use case, right? You always have a certain period where you want to not only test stuff, but have some type of human feedback loop. I think that still holds for most use cases. So, looking at how I would, let's say, structure this, I wouldn't necessarily ask, like, is this an automated use case or not? If something can be automated and it results in a lot of time save, that is, of course, I think a very nice thing to have. But the main question is, say it's not fully automated yet, but it's human supervised. How much time are we already saving with that, right? And maybe the step from going to a system which is either human assistant or human supervised to fully automate, maybe that's still a very big step, right? And in terms of implementation, but do you not gain as much from that? So that's why I would map out any type of use case that you have. I would map them out against these 4 levels, and then make an informed decision about how far would you want to go with your automation. Yeah, that's how I would do it, to be honest. And of course, there's never a perfect route, but I think that would deliver the most results in the shortest amount of time.
Yeah, okay. And let me chime into one of the last parts where you're talking about how much gain is there still from doing the step, for example, towards full autonomy. So do you mean with that also that we are talking a bit about diminishing returns there?
It could be, right? So you can imagine if you have a process where loading in the data is a lot of work, right? And it's extremely complex and a hard thing to do, right? So if that's 80% of your process, right, then and I work it up until a way where I just need to validate it, then I already saved 80% of my time, right? I'm spending 10 or 15% more time on validation, but then I still have a relatively big impact on my use case, right? And then if the automation step, it saves me that 15% validation, is it then still worth it? Right? That's a little bit of the question. And so I don't think it necessarily holds true that it's that moving from semi-automatic to automatic will have just as much impact as moving from manual to semi-automatic.
Yeah.
So and I think that's your conclusion or idea as well, or are you seeing that differently?
Yeah. So yeah, indeed. So what we did is we illustrated also how we feel in customer use cases the value maps against the automation. So what we often see is that going from a manual step towards some level of automation, so assisted, so the human is still in control, or autopilot, so the human more supervises the system, has a lot of gain. And then maybe going for full autonomy, that's a lot of work in validating and still doing extra checks. That maybe the extra gain can often be a bit exaggerated, right? Not that much. So what we really try to do is work with the customer, maybe challenge the customer also in what automation level is right for them.
Yeah. But the end goal is, of course, to become fully automated, right? Or in the long run?
Still, yeah. That is still for sure the end goal. But when we encounter a manual process, let's maybe not go directly for full autonomy if we can take it step by step and get already more a lot of value in assisted or autopilot. And where the investment for full autonomy, okay, so maybe there are some use cases it makes most sense, right? Let's take this process, we're going to completely map it out, work together, get a solid system in place, fully automate it, right? But we just want to also challenge the case where it sounds kind of promising, right? Hey, we can fully automate this, but we want to be pragmatic. What has value and what makes sense to do first.
Yeah, that is clear indeed. I think that's a very good insight, a very good learning. And building on top of that, so we promised our viewers, listeners, multiple use case. I think you mentioned two, right? So one for claims auditing effectively, and another one that had to do with basically ingesting large PDF files and being able to do that in a structured way. So do you have any other, let's say, cool last use case that you might want to share that you thought, okay, this was actually pretty cool use case which you put into production?
Yeah, I do have. So let's dive into a third use case, which is a project that we have done in collaboration with Avrotros. So Avrotros is a Dutch media company. And what their goal was at the start of this project is they want to get a more systematic insight into viewer counts for their programs. So they broadcast a range of different programs, and they want to get a better insight in which parts exactly are popular or very unpopular. Who is speaking? So, for example, you have the Dutch talk show Eva, right? Where she sits at a table, just like we are now.
Just like us, yes.
Yeah. And which topics attract viewers? So that they found it actually valuable enough to get these insights that they manually label these things, right? So from minute 1 to minute 6, we are talking about the war in Ukraine. And then a next topic starts. And so for this first topic, exactly these people are involved.
Yeah.
And they want to get access to that type of data, which they now do manually, automatically. All all right. So how did we tackle that? So this use case had a bit more different facets than just data extraction. So we see a combination of different techniques to tackle this.
Okay.
So first we are taking the audio of the episode, and we can transcribe that, and with an LLM, use the transcription to create chapters.
Okay.
So the transcription also comes with timestamps, so we know when a chapter, like a topic, starts at any given time. Then what we also want to do is we want to detect the faces of everyone that is visible in the recording. So there, one challenge that we saw is that face detection systems are quite performant these days. So it had no problem picking up also background people in the background.
Oh, cool. Oh.
Yeah, so they were much smaller, but then it would also pick them up, which that is really good that face detection works so well. But in our use case, we just want to identify what are the speakers.
Yeah, indeed. Yeah.
What are the main people? So there we also take into account what proportion of the image is this person taking up. Because if you are visible at the front of the camera, you are sharp, right? So not blurred, and you take up a large proportion of the screen, then it is very likely that you are one of the key persons.
Yeah.
So we do that. We get that for every frame in the video. Then we convert these detected faces to embeddings, and we can also group them together. So once we embedded that, then it is also highly likely that the embedding of your face under a different lighting condition will also be close to each other.
Because it's similar. Yeah,
exactly. So there we already know, okay, which person was involved in which topic by having their face mapped to a certain topic. What we also then want to extract, so from a certain piece of text in the transcript, we can also detect, okay, what is the topic, and that in a way is also some structure, right? The chapters, the timestamps, which we can also then kind of assemble all this information with an LLM. So this is a use case where a lot of different kind of parts are moving, playing around together.
So to put it more, let's say, plainly, so you build a system that based on a certain recording, for example, from a talk show, was able to, transcribe the sound to text effectively. It was able to categorize the text, right, in different chapters. Then it was able to also recognize the person that the text belongs to, right? So the person speaking, and able to classify that. And then based on all those components, you were able to categorize them, but also, for example, put viewing rates on top of certain sections, I'm assuming.
Yeah.
That is, okay, that's very interesting. Yeah. And that was all built on top of LLMs, effectively. Or also some traditional machine learning still in there.
Yeah, so a combination, right? So this solution was built on top of Google Cloud, and we use very new techniques. So we use some latest Gemini model, but also in combination with face detection is technique that already matured over time. So right, so that's more traditional. So we just use plain face detection. And also the image embeddings, right? Yeah. It's kind of another technique where we do insert that into a vector database, into a similarity search, but doing image embeddings, that's not an LLM, right?
Yeah. And this is now fully automated. And before this was more of a manual thing that needs to be done.
So yes, but of course also checks, right? Human in loop. So there we can run that system, so it runs on a schedule. Picks up on new episodes. So that's just video files arriving in some bucket where we trigger again our script to do this entire analysis, dumping the data at a place that's reachable for a dashboard. And then this dashboard on its turn, there's also some logic where we aggregate with the view counts, right? So we have all the topics and the persons and then the view counts, and then we have kind of all the data packed together.
Nice. Cool. So I think Afrotros is very happy with that. Look at the time as well, maybe as a very last question. So we talked a lot about GenAI, right? We talked about some of the use cases. What do you think, what will be the big next thing? Or what do you think, this domain will move into? Or what are your thoughts about that? If you can tell us one thing, like this is what we need to watch out for, this interesting, or what would it be?
Yeah. That's a very interesting question. So we can look a bit in our globe, right? See where things are going.
So predict the future for us. That's what I'm asking.
So what I think will be an interesting development is that we can see that this technology is maturing very fast. And companies are getting more familiar with it, but also all the solutions, managed solutions, are also getting more stable, right? So what I think is an interesting development is that we see both high code, low code solutions, then targeting also a bit different groups. So whereas previously domain was exclusive to machine learning practitioners, you had to train deep learning models to do this type of stuff. So since GenAI, this is exposed as an API, it also became a lot more easy to build products with it. So we have now also offerings like Copilot Agent Space, so one workflow automation tool, N8N, with which you can do without having all the specific technical knowledge, you can achieve already a lot, right? So an interesting development that I think will be happening is that from a bit, Wild West, right? Or you can do a lot of useful things with GenAI. I think we're gearing more towards like an ecosystem, right? So someone exposes an agent, like a lot of software manufacturers expose also their tooling, for example, via MCP. So they also include MCP server with their SaaS product, for example. And we can more tap into that, right? So we can see an ecosystem, becomes more plug and play. We can let services talk to each other. And we can both tap into all that offering these marketplaces also, if you will, from the low code perspective. And then maybe business users can also get some gain from this. And high code, where we go for very complex use cases.
Okay. And so if I would interpret it, you're effectively saying that we might still see a lot of acceleration happening using GenAI. Now that low code becomes more available, and you have business users that might be able to use no code tools to build these type of agent integrations. You think that that will have a relatively high impact on this domain?
Yeah, I really like the word accelerate that you're using here, right? So I think adoption will get a lot higher, right? If companies also get more comfortable with using these technologies, the threshold also becomes lower to step into that, right? At the same time, so companies get more comfortable, it becomes less scary, and the solutions also become more stable themselves as well. So I think indeed this will quite accelerate. And do you have also any predictions for the future now that we're still talking about this?
Well, look at the time. I think my prediction is that your prediction will be right. So we
very
will
well,
definitely
very
be
well.
seeing. So I think this will have a high impact as well. But thank you for your insights, Jeroen, and thank you for joining us. And of course, thank you for the viewers. Thank you for joining us today. We hope that you enjoyed the conversation. If you like to stay updated, be sure to subscribe, as well as share your thoughts or comments that you might have on this episode down in the link. And we would love to hear from you. Thank you.
Thanks.